Now we're going to see what is the energy that could be stored in a capacitor or a condenser. So here we have a parallel plate capacitor. This has an amount of charge Q positive and this Q negative. So if we have could be a circuit here. This is the capacitor and this is the battery. We have a capacitance that would be the charge divided by the voltage. In future video we will see what happens if we discharge the capacitor and the circuit is connected or disconnected of the battery. But here we want to see how much charge could be stored here. So when this voltage is on, the current is going, from this is the negative terminal, this is the positive terminal, and the charges are being stored here. Here we will have a positive charge and a negative charge stored in each plate. The amount stored would be the same, but with opposite charges. When we say how much charge could be stored, we mean just, for example, how many positive charges could be stored in one plate, because that would be the same as negative charges stored here, but it is not twice. It's just when we say how much charge could be stored, we are talking about in one plate. Alright, so you can think it as what is the work done from putting the plates, from separating the plates until this distance D. In that way, we have the electric field here is not just epsilon naught, is not just sigma divided by epsilon naught, because if you take this plate, that is the one that we are separating, this plate is not completely plain, it's like this. The charges are negative in this part, and here we have no charges. So the electric field at this point is epsilon naught, is sigma divided by epsilon naught, and here is 0. So the average electric field is epsilon naught divided by 2, or one half of sigma divided by epsilon naught. Then we have that the work is equal to force times distance, but the force is the electric field times the charge Q. Here we have a plate that has a surface density sigma. So the surface density is the charge divided by area. So the charge is area times the surface density. So here we have that the work is 1/2 of the electric field. So it's sigma divided by epsilon naught. This is the electric field, is this part. Then times Q to have the force. Q is area times the charge density, and then times the distance of separation. You can put it H or D. So H. And here we have this, you can put it as electric field, and you can multiply by some convenient one. So epsilon naught divided by epsilon naught. And so we would have sigma divided by epsilon naught. So we have that the work is 1/2 of the electric field square. This is one electric field. This would be another electric field times epsilon naught times area times distance, that is the volume. So this is the work done. You can put the this is the work done that would be stored as electrical potential energy. If you want the work density or the energy per density, that is energy per volume, you divide the work with volume, and so you just have 1/2 of epsilon naught times the electric field.